Hey, what is going on everyone? I'm Wicked and today it is time for me to introduce you to another important topic on this Block from Zero to Hero tutorial series. Remember that in the last video we talked about the standalone block concepts like streams, blocks and qubits. Well, they will serve as the foundation to the Flutter block concepts we'll cover up today. So without further ado, let's get right into it. There are some important basic Flutter concepts you really need to understand before getting our hands dirty with Flutter block concepts. So we will begin with these first in order to make sure everything goes nicely into place. Let me start by highlighting the proverb everyone interested in Flutter heard at least once. Everything in Flutter is a widget, right? So smash that like button if you knew that. Well, since in this video we'll be discussing Flutter block concepts, you must know that every concept is actually a widget. But what exactly is a widget? Widgets in Flutter are classes. Classes which have their own attributes and methods. These classes can be instantiated as objects by defining their required parameters and methods into their constructor. As an example, let's take a look at the floating action button widget. As you can see, there are all sorts of parameters passed through the constructor of this widget. The foreground color, the background color, the onPress function and many more. If you tap Ctrl and click on the widget, VS Code will open a tab which contains the floating action button widget, which, as I told you, is actually a class with all kinds of attributes, from primitive types like booleans, strings, doubles, integers, to functions and even other widgets. You may have also noticed that some widgets have a child parameter. Well, what could be that for? Well, since everything in Flutter is a widget, there must be a way for the framework to keep them organized, right? And what's a better way to nest and organize stuff than using a tree? Observe this picture. Take a look at the top of the tree. That's the root node. Below that, you can see two other widgets emerging from it. These are the children. The above widget is also called the parent widget or the ancestor, and that's how the tree evolves for every widget until there are no more children inside the tree. Now that we know what a widget is and how Flutter organizes them, let's start with the first Flutter block concept, which is BlocProvider. Now, a quick note so that you won't get confused. Remember that in the previous video I talked about qubits and blocks and the difference between them. Well, there won't be a block provider and a separate qubit provider in this case. Qubit is a smaller part of a block, so it works the same as a block with BlocProvider. Hence, every Flutter block feature I will discuss today will apply to both qubits and blocks. So have you ever asked yourself after you build your first block, how will you access it in your UI? How will you access it inside Flutter in the first place? You might say that you will create a block object for every widget where it may be useful. If that's what you're thinking, well, it's actually pretty wrong. I mean, extremely wrong. What if you have an internet block which manages the current state of the app in different network scenarios? Think about how many widgets should have a working instance of the internet block available. So, creating an instance for every widget that needs it is a terrible idea. Instead, what you must use is the BlocProvider widget. BlocProvider is a Flutter widget which creates and provides a block to all of its children. This is also known as a dependency injection widget, so that a single instance of a block can be provided to multiple widgets within a subtree. In other words, the entire subtree will benefit from a single instance of a block injected into it. Hence, the subtree will be dependent on the block we're providing. So for example, if we instantiate a block provider with a block A here at the top, it will be available through the entire subtree below it. If we instantiate it here in the middle part of the tree, the block instance will be available only to the nodes below and to none of the ones above it. Notice how BlocProvider creates the single instance of the block using a function, which takes the build context as an argument and returns the only one instance of block A. Build context is like its name is implying, the context in which a specific widget is built. So we'll have the current widget context and we'll be instantiating the block A to all of its widgets in the subtree. But how can we access it in the subtree? The single instance of block A can be accessed by calling BlocProvider.of block A context, or even simpler by calling context.block of block A. An optimization technique BlocProvider offers is that by default it will create the block lazily, meaning that the create function will get executed when the block is looked up for via BlocProvider of block A context, so that there won't be a ton of created blocks when they're not needed inside the app. To override this behavior and force the BlocProvider's create function to be run immediately, as soon as possible, lazy can be set to false inside the widget's parameters. Take in mind that even though BlocProvider is responsible for creating the block, it will also automatically close the block so that there won't be any stream leaks all over the place. Okay, so this is what happens locally when you have only a screen in your app. But what is it going to happen where there will be a new portion of the tree available to the existing one? This scenario can happen when we push a new screen into the navigation routing feature of Flutter. Is the block A going to be available there too? The answer is no, and that's because there is another context created on the new route, a context which the BlocProvider doesn't know yet. So in order to pass the only instance of the block to the new route, we will use BlocProvider.value, in which we'll pass the block A to the value parameter, thus making the instance of it propagate through the next widgets. Note that in this case the BlocProvider.value won't close the block automatically, since we still want the block to be accessible into the ancestor tree above. Since we initially instantiated the block with BlocProvider, it will, as I said, handle the closing part automatically. This was a brief introduction on how block can be accessed inside Flutter, but we will have a separate video in which I'll talk more in depth about block access across every possible scenario. Now, as an example, to make sure you understand the BlocProvider concept by actually practicing it, we will start implementing the default counter app from Flutter using BlocListener. So let's start by creating a Flutter project. You can name it whatever you want and then add the flutter_block dependencies into the pubspec.yaml file. Note that I'm also using the block VS Code extension, so I recommend you to download it because, believe me, it will make your life easier along the way. Since the counter feature of the app we want to implement is really simple, we will start by creating a new qubit called counterQubit. From here, I will start by coding an implementation that will be more extensive and self-explanatory instead of a quicker and abstract one. I'm doing this so that you'll understand all the concepts really well. So in the folder created by Qubit, we'll open the counterstate.dart file and modify it so that it only includes the counterState class. This class will be the blueprint for all the possible states which will be emitted by the qubit. Since this class must have the counter value, let's write it down and also create a constructor for it. The application must have a valid counter value at all times, so every time we'll have a new state emerging from the qubit, the counter value must be a required attribute, hence annotating it with the required keyword. Now, inside the counterQubit file, firstly, we need to set the initial state of the counterQubit. Can you think about what the initial state is? Well, it is definitely going to be a state, so we'll select the counterState class. Then, as you can see, we'll receive an error inside VS Code telling us that the counter value parameter is required, so we need to pass it inside the constructor. The initial state of the counter app will have the 0 value, so we'll set the counter value to 0. Then all we have to do is implement the increment and decrement functions which will emit new counter states. So the increment function will emit a new counter state, with a new counter value passed into its constructor, a counter value which is going to be equal to the current counter value plus 1. You can access the current state of a qubit by using the state keyword. This will return an instance of the current state of our counter, and by saying state.counterValue, we'll receive the counter value of our current counter state. The same procedure applies to the decrement function, the only difference being that instead of adding 1, we'll subtract 1 from the current counter value. Okay, so we finally created the counter qubit successfully by using everything we learned in the previous tutorial. Now it's time to link the qubit to the UI using the first concept we learned today, the BlocProvider. As you can see in the main.dart file, the top of the tree is actually the material app widget. This is where the tree starts from in most of the Flutter apps. So, from what we've learned today, in order to make our counter qubit available throughout the entire tree of our app, we must create a block provider with it at our material app level. So all we have to do is select the material app and then click Ctrl+period to open up this dialog, and then select Wrap with BlocProvider. I told you the block VS Code extension will come in handy. Then into the create parameter, all we need to do is to take the current context and return a counter qubit instance. Make sure you also import the flutter_block up there into the import section. Okay, so what we did now is we told Flutter to create a single and unique instance of the counter qubit and make it available to the subtree below material app widget. Onto our homepage, we will adapt the code a little bit by adding a row child to the column widget, a row which will contain 2 children, the 2 floating action buttons which are supposed to increment or decrement the counter. Remember what I said when we started learning Block? That for every interaction a user makes with the app, there should be a state emerging from the app letting the user know what's going on. Having that in mind, we conclude that for every tap of either of these 2 buttons, there should be a new counter state, perhaps counter value, shown on the screen. To do that, we need to call the increment or decrement functions on the qubit instance. But how do we access the instance of the qubit? As I told you before, either by calling BlocProvider of counterQubit context, or with context.block of counterQubit. Then all we have to do is to pass the increment/decrement functions onto the onPress parameter on the floating action buttons, which tells us that every time we press one of these buttons, the qubit.increment or decrement functions will be called, adding or subtracting 1 to the current state. The question now is, how do we receive the new state inside the UI? How do we rebuild the specific text widget which prints out the counter value? It is now time to introduce the second important Flutter block concept, which is BlocBuilder. BlocBuilder is, as its name suggests, a widget which helps rebuilding the UI based on some block state changes. This is the magic component which rebuilds the UI every single time a new state is emitted by either block or qubit. If you watched my previous video on block concepts, you have to know that this block builder is actually you waiting for the boat your friends sent down the river. You are the block builder waiting for the boat and its number so that you can rebuild the UI by calling the number out loud. Now, you have to understand that rebuilding a large chunk of the UI inside your app may take a lot of time to compute. So that's why a good practice would be to wrap the exact part of the UI you want to rebuild inside BlocBuilder. For example, if you have a text widget which updates from a sequence of emitted states and that text is inside a ton of columns, rows and other widgets, it is a huge mistake to rebuild all of them just to update the text widget. Instead, what you should do is rebuild only the text widget by wrapping it inside BlocBuilder. Syntax-wise, BlocBuilder is a widget which requires a block or qubit and a builder function. the builder function will potentially be called many times due to how Flutter engine works behind the scenes, and should be a pure function that returns a widget in response to a state. So what is a pure function, you may ask? Well, a function where the return value depends only on the function's arguments and no others, thus making it pure. So in this case, our builder function should return a widget which only depends on the context and state parameters and nothing more. If the qubit or block is not provided, the BlocBuilder will automatically perform a lookup for its instance using BlocProvider and the current build context. Now, for even more control of when should the BlocBuilder rebuild the UI, there is another parameter which you can use called buildWhen. This should take in a function having the previous state and the current state as parameters. For example, if the current state contains a text value and that text value is greater than the previous state text value, you can return false so that the builder function won't trigger and won't rebuild the UI. Okay, so it is now time to integrate BlocBuilder with our counter app example. We left the app open inside the main.dart file. The counter value of the app should be printed right inside this text widget right here. Now all we have to do is to wrap this specific text widget into a BlocBuilder by clicking Ctrl+period and selecting BlocBuilder. Note that I could have wrapped the entire center widget with a BlocBuilder instead, but that would be wrong performance-wise, since the builder function will rebuild the entire widget tree instead of only the specific part we're interested in, which is the text value. Okay, so now into the builder function, for every new emitted counter state, the text widget will show a new value. The value can be accessed by calling state.counterValue and then by converting it to a string, since we know that the value is actually an integer. It is finally time to test out our app, a moment which we've been waiting for so long. So let's run it together. As you can see, when I'm pressing the plus button, the counter qubit calculates the new counter value, emits a new counter state with the new counter value, and then UI rebuilds with that specific value. To make this rebuilding process even more clear, take a look on how I can play with the emitted states. I can check whether the state.counter value is negative and print a negative text widget. I can check if the counter value is even and print yay. Or I can check if the counter value is equal to 5 and print number 5 into the UI. I hope you can now understand the power of streams, states and BLoC. It may seem like BLoC is a little overkill for a counter app, but in order to understand the concepts, we need to try them on simple examples and then see the power of it and what amazing apps and features you can build by using it. I hope you understood the BlocBuilder concept, because it's now time to move on to another Flutter block concept, which is BlocListener. BlocListener has mainly the same structure as BlocBuilder, but it is really different in many ways. You see, the BlocBuilder function can be called multiple times inside the Flutter engine due to how Flutter engine works behind the scenes. So for example, navigating to another screen can't be done inside BlocBuilder as a response to a state change, because this action can be actually done multiple times. Imagine the builder function inside being called 5 times. Would you want the new screen to be pushed inside the navigation stack 5 times? No way. Or what if you want to show a snack bar or a dialog for a new arriving state? The builder function may be called 4 times by the Flutter engine, rebuilding the UI accordingly, but the snack bar will be shown 4 times, as well as the dialog box, which pretty much is not what we want. This is where BlocListener comes into place. As its name suggests, this is a Flutter widget which listens to any state change, as BlocBuilder does. But instead of rebuilding a widget, as BlocBuilder did with the builder function, it takes a simple void function called listener, which is called only once per state, not including the initial state. Again, for fine-grained control, there is also a listenWhen parameter function you can pass to tell the BlocListener when to call the listener function or not, as buildWhen parameter was for the BlocBuilder widget. To understand BlocListener easily, what we want to do is the following. Every time the user presses plus or minus buttons, there should be a snack bar showing in the bottom part of the screen, saying incremented or decremented, depending of course on which button was pressed. Can you guess how we're going to do that? Let's start with the beginning. So what happens when we press either of these two buttons? The increment or decrement function from inside the qubit gets called. What do these functions do? Well, they emit a new counter state with a new increment or decremented counter value. So this is mainly where Flutter understands what the press button does. And this is where we should tell Flutter's UI through a state that we incremented or decremented the value. So all we have to do is to add another Boolean attribute to the counter state class, calling it wasIncremented. This wasIncremented field will be true when we press the plus button and false when we press the minus button. We can go into the counter qubit class and modify the increment or decrement function accordingly, setting up the wasIncremented parameter as we discussed. And now we can go back inside our BlocListener, and based on our state's wasIncremented attribute, we will display a snack bar accordingly to whether the counter value of our counter state was incremented or decremented. And voila! You can see from the screen that our application works as we want it. So perhaps you're in our situation right now, when you're updating the UI using BlocBuilder and also showing a snack bar using BlocListener. Isn't there an easier way to do it? Of course there is. It's called BlocConsumer. BlocConsumer is a widget which combines both BlocListener and BlocBuilder into a single widget. How convenient! So instead of writing BlocListener on top of BlocBuilder, as we did in our example actually, we can refactor the code by writing both of them inside the BlocConsumer widget, and then copy and paste the necessary content from BlocListener to the listener function and the content from BlocBuilder to the builder function. And voila! The code is now more readable and easier to maintain, and the application works perfect. Another amazing Flutter block concept which you'll use a lot is RepositoryProvider. RepositoryProvider is the same exact widget as a BlocProvider. The only difference being that it provides a single repository class instance instead of a single block instance. We will talk about repository more thoroughly in future tutorials when I'll introduce you to the block architecture. In a couple of words, a repository is a class which has the main functions which make Flutter communicate with the outer data layer, the internet, the APIs, the databases, and so on and so forth. Again, we'll cover these concepts in depth in future tutorials. In more feature-rich applications, you can imagine that there will be maybe tens of blocks and qubits having their own functionality. In this tutorial, we talked about how we can provide only one block or qubit to the UI. But what are we going to do when we have 10 blocks to provide and 10 blocks to listen to when we want to display 10 different snack bars? We will stack them together one after another? No, we will definitely use MultiBlocProvider, MultiBlocListener, and even MultiRepositoryProvider. So these are mainly the simple concept widgets we discussed before, but instead of taking only one block or qubit or even repository, they can take as many as they possibly can. Okay, so it is finally time to wrap things up. If it's the first time you saw these concepts, this might be a pretty difficult tutorial, and I recommend you to watch this video at least twice and then try to build this counter app by yourself so that you can understand the Flutter block concepts by practicing instead of just watching the tutorial. However, in the next tutorial, we'll dive into block architecture and how easier it will be for us to organize and maintain every app. Until then, take care, stay safe. This was Wicked from Flutterly, and I'm out.